Welcome back. We're looking at section 1.2 in our notes, sets of real numbers. So we're going to work on classifying or putting numbers that are rational and irrational into categories. So what helps here is to actually know the definitions of the different numbers that we're going to work with. So we have a few different categories of numbers here that we're going to deal with. The first one is our whole numbers. Our whole numbers are our positive counting numbers plus 0. For example, 0, 1, 2, 3, 4, and so on all the way up. Okay, they are our whole numbers. Our second set of numbers that we've learned about is our integers. These are our whole numbers, our 0, 1, 2, 3, 4, but also the opposites of them. So the negative 1, negative 2, negative 3, negative 4. Okay, it's important. Integers are whole numbers. Integers cannot be decimals. Okay, they can be written as fractions, but there will not be decimals. There will not be any kind of fraction bar. Okay, we see them as positive and negative whole numbers. Rational numbers are any numbers that can be written as a fraction. Okay, so 1/2 is an example of rational number, 0.35 is an example of rational number, even 6 is a rational number because we know that we can turn a whole number like 6 into a rational number by putting it over 1. Okay, and then we have our new set that we haven't talked about this year, and these are our irrational numbers. These are any numbers that cannot be written as a fraction. Okay, right now we only have one type of number that we have dealt with that is irrational. Okay, and that is square roots that are not perfect squares. Okay, the square root of 16 is a perfect square because 4 times 4 gives me 16. So it's a whole number answer. I can put that number into the whole number category. Okay, numbers that fit into this category are numbers like the square root of 17. Okay, there isn't a number that you multiply by itself to give you 17 exactly. We can get really, really close. We'll talk about that later, but we won't get there. Okay, these are our square roots that are not perfect squares. These fit in the irrational number category. And real numbers are all rational and irrational numbers. So every number we've dealt with so far, every number you're going to deal with in 8th grade, everyone you might deal with up through Algebra 1 are all real numbers. So when we classify them, all of these numbers fit into the real numbers category. And remember, we classify them, we have to put them in all the categories they fit. So if we're looking at like the number 3, 3 is a whole number. It is also an integer because it is a positive or negative whole number. And it's also a rational number because we can write it as a fraction by placing it over 1. And, like I said, all the numbers we deal with are real numbers. So if we were classifying 3, it would fit into a bunch of different categories. Let's actually classify some of these numbers, and we'll put them in a chart, and then we'll tell what categories they go with. Okay, so let's look at A. A is the square root of 5. First thing I need to do is see if I can simplify it. Is the square root of 5 a perfect square? Turns out the square root of 5 is not a perfect square. Okay. In the last section, we said if it's not a perfect square, then we know that is an irrational number. So therefore, it goes into the category with irrational numbers. Okay, so it is irrational. That is the first category it fits into, and I always place all the categories the number fits into. Well, if it fits into irrational, it's also in the real numbers because this whole set of numbers fits into the real number segment. So it's irrational and it's real. B, we're looking at negative 17.84. The easiest way to do this, it's not irrational because it's not a square root. So it's going to be on our left side here. I start with the smallest category and I work my way out until I figure out what category this number fits into. So negative 17.84 is not a whole number. It's not an integer because there's a decimal at the end. Therefore, it has to be a rational number, and we've actually written decimals as fractions in the past, so you should know that negative 17.84 goes here, which means it's rational, and like I said, all of your numbers here are real numbers. C is the square root of 81 over 9. Again, we always look to simplify before we do anything else. The square root of 89 is a perfect square. The square root of 81 equals 9, sorry, not 89, over 9. Remember that a fraction bar is just another way of using division. So this is really the same as 9 divided by 9, which is 1. So this number will fit into any category where 1 fits. So it's a whole number, but because it's a whole number, it's also an integer and it's also a rational number, because that's what this Venn diagram shows. All the whole numbers fit into the integers category, all the integers fit into the rational numbers category, all the rational numbers fit into the real number category. Okay, so if it fits in whole, it also fits in integers, and it also fits into rational. And like we said, all of our numbers that we're going to do this year are real. Okay, so look at the definitions, compare the definitions to the number, and figure out exactly what categories these numbers fit into. Okay, that's sets of real numbers. If you have any questions, please ask, leave a comment, or do whatever you need to do.